Hi, in this video we'll try out the two-way chi-square test in Excel. With the two-way chi-square test, we have two nominal or categorical variables. And so we talked about frequencies of nominal variables in the beginning of the semester. And so I'm actually going to use that same data set because we have two variables. We have our eyewear variable and we have our accuracy variable. And we have two different options for each variable. So for eyewear, we have people who wear glasses versus those who don't. And for accuracy, we have correct versus incorrect. And so my research hypothesis may be that I expect a relationship between my eyewear variable and my accuracy variable. Maybe I expect that people who wear glasses will be more likely to get the answer correct. And my null hypothesis is that there is no relationship between these two variables and that we shouldn't see any relationship between wearing glasses and be more likely to get the answer correct. So to fill in my frequency table, I'm going to use a variation of that COUNTIF function that we talked about earlier in the semester. And so I'm going to type in my formula into this cell. And in this cell, I want all the people who wear glasses and got the answer correct. So I'm going to type in COUNTIF, and if you notice there is a second option here, COUNTIF with an S. So I'm going to click that one because I have two separate criteria. I have wearing glasses and getting it correct. So for the first one, I'm going to select my column A. I'm going to say that my criteria is that I want all the people who wear glasses. And then for my second criteria, I'm going to select column B. I'm going to say I want all the people who got the response correct. And close my parentheses and press enter. Now here, I want COUNTIFs. I want all the people who didn't wear glasses. So no glasses. And got the response correct. We have 93 there. Over here, I want all of my people who wear glasses but got the answer incorrect. And finally, I want all of my people who do not wear glasses, no glasses, and got the response incorrect. All right, so I have filled in my table. And so as we talked about, my total sample size would be the sum of all of these cells. And so I'm going to type that in. So I'm going to type in sum, and I'm going to select all four of these cells and press enter. So my total number of participants is 252. So let's see if that matches what we should get. Yep, 252. So that's my total number of participants. But I also want to get my row and column totals. So I'm going to sum across my rows. And I'm going to sum across my columns, or down my columns. Here, enter, and check again. All right, so I have the total number of people who wore glasses, the total number of people who didn't, the total number of people who got the response correct, the total number of people who got the response incorrect. So this is my observed frequency table. And so what I want to do is to next create a table for my expected frequencies. So when we did this by hand, we said that we get our expected frequency for each of these 4 cells by looking at the row total multiplied by the column total divided by the total number of participants. So what I'm going to do is just copy and paste this and delete out to get my expected frequencies. So I'm going to say equals my row total multiplied by my column total divided by my total here, my total number of participants. Let's see what happens when we just pull across. No, it's not gonna let it, but we can edit this. So let's see where it has made a mistake. So I'm just gonna move this over, press enter and see what we get. Oh, perfect. So it's taking I5 multiplied by H7 and divided by our I7, which is our total number of participants. Let's see if I pull this down. This one didn't quite make it either, but we can fix that. So let's see here. So I6 multiplied by G7 divided by I7, perfect. All right, and let's pull it over. And again, it's not quite what we wanted, but we're going to tell it, okay, we want I6 multiplied by H7 divided by that. Enter. Oh, nope. Oh, there we go. Okay. I'm going to move this over like that. All right, perfect. So we have our expected frequencies. Oh, we have something going on here. Let's see, what should this be? Oh, we had edited this other one. That's where we messed up. So this one, we want to move it back over here. Perfect. Okay. And you can type them in if you find that a little bit easier than moving over squares. But this would be our expected frequencies. And so in your homework, or sorry, your quiz, I actually filled in these formulas for you. So as soon as you use that COUNTIFs function to get your observed frequencies, it will fill in for you the row totals, the column totals, the total number of participants, and it will fill in your expected frequency table for you. So this is just kind of, if you wanted to do that yourself, how you might go about doing that. Now, to calculate our chi-square test, we're going to have to do that using formulas because there's no option under the data analysis tool pack to conduct a chi-square test. And so I'm going to type in a formula here, and I'm going to type in chi and look at my option. One of my options is the chi-square test. So CHISQ.test. If I click on that, we can read about it, and it says it returns the test for independence. So it's going to return my probability or my p-value for the chi-square test. So if I click on this, I first need to select my actual range, which is my observed frequencies. So I'm going to select my data that I used, that I got with my COUNTIFs function. So I'm going to select these 4 cells here. I'm going to select or press comma, and then tell it the expected range. So my expected frequencies were these 4 cells here. I'm going to close my parentheses and press enter. So my probability value is 0.076. So we know that it's not statistically significant. Remember that we're looking at p less than 0.05 or equal to 0.05. So this is larger than 0.05. It is a little close, but we can also get our actual chi-square value. And so if we wanted to get our chi-square value, we type in equals chi, and we're looking for this one, chi-square dot inv rt. And so we're going to select that. It's asking for the probability, which we calculated as 0.076. So I'm going to select that cell. I'm going to type a comma, and it's asking for the degrees of freedom. So we said that for the two-way chi-square test, you have the number of categories of variable 1 minus 1 and the number of categories of variable 2 minus 1. So each of our variables has 2 levels. So if we subtract 1, so we've got 1 multiplied by 1. So our degrees of freedom is 1. I'm going to close my parentheses and press enter. So my chi-square value is 3.15. So if we were to report our results in APA format, it may look something like this. So I state my total sample size. There are a total of 252 participants, or wait, 252 participants. I report what test I ran. So a chi-square test of independence was performed to examine the relationship between wearing glasses and accuracy. I state our research hypothesis, our null hypothesis, and then I report that the relationship was not significant. I report my chi-square. This is my degrees of freedom of 1, my chi-square value, my p, and my p-value of 0.076. And then I say that we did not support our research hypothesis, and the null hypothesis was retained. So if you're wondering where I got this kind of funny character here, I just went up and said insert, and insert symbol is one of my symbol options where you may have to click more symbols. And then I clicked here to get my superscript to put in my squared for my chi-square. So I will post this example right up on Canvas as well. And so what you can do is just copy and paste and then put in your values that you need.